Think about this for a second. Every time a car passes over a bridge, every time a subway rumbles underground, even when you simply walk down a hallway, something invisible is happening. Tiny vibrations ripple through the ground, through the walls, through the very floors we stand on. Most of the time, we don't notice. The energy just fades away, gone in an instant. But here's the fascinating part. Researchers are now finding ways to capture that wasted energy and turn it into electricity. Yes, the simple act of walking, driving, or even footsteps in a quiet corridor could help power the devices of tomorrow. City streets are never truly still. Bridges tremble slightly when traffic flows over them. Subways send low, steady rumbles through the ground. Even in buildings, footsteps create ripples of motion so small we don't feel them, but sensitive instruments can detect them easily. Until recently, this energy was considered background noise, something to design against, not something to use. Engineers worked hard to make structures stable and absorb vibrations, rather than asking, what if these constant shakes and rumbles could become useful? That's where new research comes in. Scientists are developing materials and devices that can harvest energy from vibrations. The concept is called vibration energy harvesting. It works by using special materials, often piezoelectric or triboelectric, that generate small amounts of electricity when they're bent, pressed, or shaken. Imagine a floor tile in a busy hallway that collects power every time someone walks across it. Or a sensor on a bridge that powers itself from the traffic moving overhead. Instead of needing batteries or external wiring, these devices would run on the energy already flowing through the environment. Now, you might be wondering, how much electricity are we really talking about? Could vibrations ever power a whole city? Not quite, at least not yet. The real potential lies in powering small electronics and sensors. Think about the thousands of tiny sensors needed to monitor bridges, tunnels, or subway systems for safety. Normally, these devices need batteries, which run out and require replacement. But if each sensor could generate its own power from the vibrations around it, they could run for years without anyone needing to touch them. The same idea could apply to wearable devices, shoes that generate electricity as you walk, powering fitness trackers or health monitors, floors in airports or shopping malls that light up or provide data just from the movement of crowds. There are several big advantages here. First, it reduces reliance on disposable batteries, which are costly, wasteful, and harmful to the environment. Second, it makes technology more sustainable, turning wasted motion into something useful. And third, it opens the door to new designs, like sensors in remote areas, where running wires or replacing batteries would be difficult. And beyond practical uses, there's something poetic about it. The simple movements of daily life, the things we don't notice, quietly giving power back to the systems we depend on. Of course, the technology isn't perfect yet. Vibrations don't produce large amounts of energy, so efficiency is a challenge. Engineers are working to create materials that capture the maximum output and systems that store and distribute this small but steady flow of power. Still, progress is happening quickly. Prototypes of vibration-powered floors, shoes, and structural sensors already exist. It's only a matter of time before we see them integrated into everyday life. So next time you walk across a hallway, drive over a bridge, or ride the subway, remember this: the ground beneath you isn't still. It's alive with motion. And soon, those invisible ripples of energy might not go to waste. They could be powering sensors, wearables, or even the small electronics that make our lives easier. What do you think? Would you like to walk on a floor that charges your phone or wear shoes that power your smartwatch? Let me know in the comments. I'd love to hear your thoughts. Because the future of energy might not come from giant power plants or massive solar farms. It might come from the simple vibrations of everyday life.